Okay, so I'll make a start now. So trigonometry. So trigonometry is all about triangles and specifically right angle triangles. So I've drawn an example of a general triangle here, right angle, and this is the angle we're interested in for our trig function. So this is called theta. It represents the angle here in this triangle. So in the triangle, we've got three sides. We've got the adjacent side. So adjacent means like next to, so it's next to the angle, so it's adjacent. We've got the opposite side, which is opposite the angle, so away from it. And then the longest length, so opposite the right angle, is the hypotenuse. So it's really important you're able to easily work out and label the triangle. I think the hypotenuse you should be able to get. It's just the adjacent and the opposite you need to be careful, especially if they're talking about like an angle up here, for example. Make sure you know which one's which. So from that, we can define the three main trig functions. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So you might have seen or you might know like something called SOHCAHTOA. So it's sort of SOHCAHTOA. And this sort of tells you which one you need. So for example, if you want to work out the opposite, then you sort of cover that up and you've got sine multiplied by hypotenuse on the bottom. Or if you want to find the hypotenuse, it's opposite divided by sine, and you can do that for all of them. So some examples of how you'd use that, and particularly how to find these angles using a calculator. So for example, if we had something like this is theta, let's say this is the right angle, this is 4 and this is 3, then we've got a few things we know how to use to work out the lengths. So this length we can use Pythagoras. So this length is 3 squared plus 4 squared, and we square root it. So this is 5. So if we call this x, then x equals 5. And then we can work out the value of this angle using tan because we've got the opposite and we've got the adjacent. So tan theta equals 3/4. And then from that, we can work out the specific value of theta by taking inverse tan of both sides. And this you just put into your calculator. So for my one, it's above the tan button. If you press shift and then click on it, it'll give you the inverse tan, and you put in 3/4 and it will tell you the angle, so 36.9 degrees. And also, because we've got this here now, we know this is 5, we can say that sine theta is opposite over hypotenuse, so that's 3/5, and cos theta is adjacent over hypotenuse, so 4/5. Okay. So that's like an introduction to trig functions. And another thing I wanted to talk about and how people often talk about trig functions is using the unit circle. So what we've got here is just a circle of radius 1 centered at the origin. So we can see like it hits 1, -1, 1, and -1 here. So let's say we pick a point on our circle. Let's say it's here. Let's say this is the point xy. Then what can we say about this point and how can we construct some sort of triangle? Well, if we join the origin up to this point here, then what do we know? Well, first of all, this is a circle of radius 1. So it's from the center to the edge. This has length 1. And what we can do is if we connect this up with the x-axis, then we can create a little right angle triangle inside the circle. So let's say this is theta. Then what do we know? Well, this length here is the adjacent, and we've got the hypotenuse. So we think adjacent and hypotenuse, that means we can use cos. So this length here is actually just cos of theta from here to here. And this length from here to here, well, what is this? This is the opposite, and we've got the hypotenuse. So using our definition, opposite is sine theta times the hypotenuse, but hypotenuse is just 1, so this is just sine theta. So this gives us a way of relating sine and cos, because we know we've got a right angle triangle. We can use Pythagoras. And this tells us that cos squared theta plus sine squared theta equals 1. So this is our first sort of trig identity that we can use when solving equations. And it all comes from the unit circle. And another one we can say is that we've got this angle theta here. Can we work out tan of theta? Well, yeah, tan of theta is opposite over adjacent. So that's opposite is sine theta, and the adjacent is cos theta. So this is 2 trig identities we can use in equations, and they can be quite useful in a lot of different contexts. So it all comes from the unit circle and connecting up points on there. So that's that, and I'm now going to go on to the graphs of the trig functions. We're going to use this to work that out. It says the audio, someone says the audio is not clear. Can anyone else hear it okay? There's not really much I can do at the moment to change the audio, to be honest. So it sort of is what it is. But I am recording this now, so hopefully the recording's picking it up a bit better, and it'll be on YouTube later today or tomorrow, maybe. Yeah, okay, just glitches a bit. I might try and buy like a proper microphone for these. That could be quite useful. But earphones could help. Yeah, I've got my AirPods connected to my laptop, and it should be recording through that, and they're normally okay, but I might try and get a proper one. Yeah, okay, well, hopefully it's clear enough. Yep. So I'm just going to I'll be back in one moment, just going to get another pen for this. Cool. Okay, so someone says, so like for the trig equations, the number used to name the line from the center to the circumference of the circle can vary. Yeah, so when we get some more, we'll go over some examples of trig equations soon. I'm just going to do the graphs first, and I'll explain how to use it, so don't worry about that. In the class, it'll be about an hour or so. It might be a little bit longer. Just an hour, maybe an hour and 10. So we've got some more information about trig. We've got our basic definitions of sine theta, cos theta, and tan theta. And we know how this relates to the unit circle. So we can start to think of some specific examples. So from this, we've got the point xy. What we've basically got here it's that the x coordinate is exactly equal to cos theta, because this is the x point here, and then the y point up here is the sine theta. So we've basically got that x equals cos theta and y equals sine theta for this specific example, not in general. So that can give us actually some information about what these functions look like, because these are just functions. They take in an angle, which is between sort of 0 and 360, or 0 and 2 pi. I'll cover radians in a bit. And it tells us like the x value. So for example, if theta equals 0, what does that mean? So the angle here is equal to 0, so it's just like a flat line. So you can think about the angle going smaller and smaller and smaller, and then when it gets to 0, it's just a flat line here. Well, that means we're over here. And what's this point? Well, this is the point 1, 0. So that's saying that x equals 1 and y equals 0. So when theta of 0, that's like saying cos of theta, which is now cos of 0, this equals the x coordinate, which is 1. So cos of 0 equals 1. And likewise, sine of 0, well, that's just the y coordinate. And when theta is 0, y is 0. And we can do this for sort of all of the other angles going around. So another one we could do is when theta is 90 degrees. This is degrees. Then what does that mean? If it's theta is 90, it's sort of a right angle up to here. So we're at this point when theta is 90. This is the point 0, 1. So that means cos of 90, well, the x coordinate of this point is 0. So cos of 90 is 0. And sine of 90 is 1. And we can keep going round and round, and that's going to give us a few points. So when theta is 180, cos of 180 equals minus 1, because we're at the point minus 1, 0. And sine of 180 is 0. So what we're doing now is we're sort of constructing what the graph would look like for these functions. So it's sort of for any sort of theta value, we get the output value. So if we wanted to sketch, for example, I'll try and keep both on the screen if possible, or roughly. If we just start with the sine ones, because you can just see that here still. So if we wanted to sketch, this is y, this is sort of, it's not really going to fit. So I'll explain it, don't worry. This is like our theta. So we can sketch y equals sine theta. So what values do we know? When theta is equal to 0, sine theta equals 0. So that means we're at this point here, 0, 0. And then when theta equals 90, so let's say that's like here, then sine of theta goes up to 1. So let's say that's up to here. So this is 1. And then again, when theta equals 180, we go to 0. So we're down here. And then what about this point here? So this is when theta is 270 all the way around here. Then our y value is now minus 1. So at 270, we're at here, which is minus 1. And then finally, when we get back to 360, which is basically the same as 0, a full rotation, we're back to where we started. So y equals 0. So you can see this is now giving us the shape of the sine graph, because we can start to sort of, as theta moves round, sine theta moves with it. So it goes up to here, and then down, and down, and up again. So this is the graph of sine theta. And we can do the same thing for cos. We can work out, when theta is 0, cos is 1. So here's 0. So let's just label it up. So always label your axes and write down what you're sketching so it's clear for people to see. So when theta is 0, cos starts at 1. And then when it's at 90, it comes to 0. When it's at 180, it goes down to minus 1. At 270, it's back to 0. and at 360 we're back to the start point, we're back to 1. So the graph of cos theta, if we connect the dots, looks something like this, roughly. So it's sort of like, well, it's exactly the same as the sine theta one, except we've just sort of shifted it along. So if you imagine it started here, then this is the cos bit, it comes down, and then it would carry on. So really, these graphs go on forever. You can sort of extend it in this direction, and then it sort of carries on up here and down again. It keeps going. They all keep going. They keep just repeating back and forth. Now, for the last one, for the graph of tan theta, how can we sketch that? Well, we know the relationship between sine and cos in terms of tan. Tan of theta is sine of theta divided by cos of theta. So if we want the value of tan, we just look at the value of sine and the value of cos and we divide them. So for example, tan of 0, well, sine of 0 is 0, cos of 0 is 1. So tan of 0 equals sine of 0 over cos of 0, which is just 0, because 0 divided by 1 is 0. So it starts here. And we can keep doing that for all of the other points. The problem comes when we get to 90, because what would we get when we do tan of 90? Well, tan 90 is sine 90 over cos 90, which is 1 divided by 0. And we know we can't divide by 0. So this is just going to get bigger and bigger, and it's going to shoot off to infinity. So what we say is that at 90, it's not defined. It doesn't have an answer. And we draw in this sort of straight line. I'll draw it a bit thicker so you can see it, which is called an asymptote. And it sort of shoots off to infinity like that. Now we also know at 180, it's going to be 0 divided by minus 1. So at 180, we're back to 0 again. And between 90 and 180, we're dividing a positive number by a negative number. So for example, it could be like a half divided by minus a half. And when we do a positive divided by a negative, we get a negative. So that means to connect it up, it needs to come up like this. And then after that, it just repeats again. So at 270, a similar thing happens, because we're going to be dividing by 0 again. So we have another asymptote here, and it goes up, and then it keeps repeating. And if it's 360, we're back to 0 again. Yeah, asymptote. Yeah, Paul's put that correct. Asymptote. So what can we see about these graphs? Well, the first two, they repeat every 360 degrees. So the sort of wording for that is we say it's got period 360 degrees. Because after 360, we're back to 0 and we start again. We just do the exact same thing. But for tan, when we get to 180, it starts again. So the period of tan is actually 180. So it repeats every 180 degrees. Okay. So these are all the tools that we're going to be using. So our basic definitions, our unit circle, identities, and the graphs, most importantly, is what we're going to use to solve some trig equations. Okay, so we'll move on to that now. So the first one, I'll just write it down. So Okay, so the first equation we're going to try and solve is sine of x equals 0.453. So this is just a number, it doesn't matter specifically. So now we've replaced theta with x, but we can still think of it as the same thing. So I've written down solve sine x equals 0.453, and that's for x between 0 and 360. Is it possible to zoom in? Not really, I've tried. Well, let me try and get something. I can try and zoom in a bit. Hopefully it's a bit clearer. It's quite clear on my screen anyway, so if you want to look back at something later, then hopefully this will be recording in a bit better quality for YouTube. Yeah, so we want to solve this equation, sine of x equals 0.453 in this range. So I think it's important to remember that when we're solving this, we can use the graphs. They sort of give us the best way of describing what this is going to look like. So if we just sketch this, what does this mean? So this is our graph, y equals sine x. And what we're saying that this sine of x, which is just the y coordinate point, equals 0.45. So we know sine goes up to 1. So let's say that's here. So 0.45 is going to be about here. So this is the 0.45. Right? So it's here and here. It's these values here, these x values here. These are the values that we're interested in. So that's what we're trying to find. So in fact, there's two solutions. So what you can't just do, well, what we're going to do is we're going to use our calculator. We're going to do inverse sine. Of this. Now let's work that out. And we get 26.94 degrees. So that's just putting it into the calculator. So that's what comes out. Then that's this value here. It always tells us the first value along. What we want to do is we want to make sure we get both of them. We can't just stop here. We want to find all of the x values between 0 and 360. So how do we do it? So we use the symmetry of the graph. So we know this is 0, this is 180. Because of the unit circle and how sine is defined, you can see sine starts at 0, it goes all the way up, and it comes down again, and it's symmetric both ways. So that means about this point here, down through 90, this is symmetric, going up and down. So if we're going 26 degrees in here, that's like saying we need to come along 26 degrees in here. So that means the other value of x is equal to 180 take away the 26.94. So we would do 180 take away 26.94, and that gives us a second solution. X equals 153.06. I've got. And you can always check if this is right. So we can do sine of 26.94 gives us 0.453. So the reason there's a few decimals here is because this has been rounded off the 2 decimal places here, so it's going to be slightly inaccurate. And We can also check the second one, 153.06, and again, we get the same thing, 0.453. So that's how we know they're both solutions. Yeah, I'll try and get a black felt tip for next time. I don't actually have any at the moment, but next time I'll try and get some. It's on my screen, it's fairly clear. So if you want to you can watch it back on YouTube. If you don't make any notes now, if you don't want to, you can make some notes a bit later. But I'll try and at least describe everything that I'm doing so you can hear like the general method. Yeah, it could be my connection, to be fair. I'm not really sure. Hopefully it gets better. Yeah, so that's how we get both solutions. So this and this, these are our two solutions. These are our two x values that when we plug it into sine, we get this answer. So I think it's really important, this is where a lot of people sort of miss out, is thinking about the connection with the graph and the equation. Sort of it all represents the same thing, and the graph tells us what values we're looking for. And we also know between 0 and 360 that there's only going to be two because we've got these two intersection points. So we don't need to worry about checking any other x values or adding anything else in to find any more. One thing I was also saying earlier is that the period of sine is 360 degrees. So that's saying that this repeats itself every 360. So what we can do is that we can say, okay, so let's say we do this sine of 26.94 gives us 0.453. We can add on 360 to that inside, and we get the same thing. So what is that? So this is 386.94. So if we do sine of 386.94, again, we're going to get the same 0.453. So that's how, if we wanted to find more solutions, say if it was between 0 and 400 degrees or 0 and 700 degrees or whatever, you can add and check your solutions by adding on the 360 degrees after you found the first two. So in the exam, it's probably worth just drawing a quick sketch. It wouldn't normally be drawn for you. Sometimes it would be, but maybe you wouldn't need to draw like a really big one like this. You could just you'd work out this first because this is just using your calculator, do the sine inverse, and then we can just draw you could just do something like this and go, okay, it's here, so we need to do 180 minus. Just something like that on the side would just give you an extra way of thinking about it. Okay. So that's the first one. Let's move on to a different example. Part B. So let's say we wanted to solve cos of x equals minus 0.77. So now we're solving a negative one, and let's do it for 0 less than or equal to x less than or equal to 360. So again, before we jump into it and put it into our calculator, which we're going to do, let's just have a think. Let's draw the graph and let's see what we're going to expect to get. So it's really important just to think about what we're going to expect to get, what the solutions are going to look like. So let's say we're going between 1 and minus 1. We're doing cos of x, so this is y. This is x. We're between 0 and 360, so that's where we're going to sketch it. Starts up here, comes down, down, up, and up again. So it looks something like this. Let's say it's here and here, which is at 180. And what does it need to equal? Negative this time, 0.77. So down here. So it's these two intersection points refer to a solution. So we want to look up to these x points. These are the x coordinates we're interested in, x1 and x2. Because remember, we're solving for x in our equation, so we want the x values. So again, how would we do this? We go, okay, Well, the first thing we do is we do inverse cos, and we get 140 degrees. So x equals cos inverse of the minus 0.77, and this equals 140.35 degrees. Now this time, what are we going to do? So last time we did 180 minus the answer, but this time we don't want to do 180 because we need to think about the symmetry again. So last time it was symmetric between 0 and 180, and that's where we did the sort of the taking away on both sides. But this time it's symmetric down the middle between 0 and 360. So this is the 360 point. So last time it was symmetric between 0 and 180. So we did 180 take away our answer. This time it's symmetric between 0 and 360. So we're going to do 360 take away our answer, because that's saying from here to here is 140 degrees. So from here to here, we also want that 140 because of the symmetry. So we also get x equals 360 take away 140.35. So 360 take away 140.35, do that on the calculator, we get x is 219.65 degrees. And those are our two solutions. So again, to check and to think about it, it's saying that when x is 140, we do cos of 140, which takes us down to here. So cos of 140.35. This is our x point in here. And then this gives us the y value, minus 0.76995, so 77 when we round it. This is the y value. So we can think of the solution almost as the coordinates of this point here. This is the point 140 minus 0.77, the sort of the x and the y values. So there's lots of different ways you can think about it. I'm just trying to give a few different perspectives, because there's people find it in different ways, but the graphs I think are the best way to do it. So sometimes you might do in school like these cast diagrams, if that rings a bell, if you've seen that. You don't need to do cast diagrams, they're really weird, and the graphs are just the way to go. So yeah, maybe put in the chat if you've heard of a cast diagram, C-A-S-T, and if you use cast diagrams, or put if you prefer the graph method. Let me know what you've used before or what you think is easier, and I'll do a couple more examples. Cast. What? So you want me to do cast? So as out of moral principle, it's something I will not do. I refuse to use cast diagrams because they are completely useless, and you don't need to. So I'm afraid I'm going to have to say no to that one. You don't need to use them. They're not needed. It's not a case of you don't need them. And what I'll do is I'll do one more example, and then I'll do the rules for solving trig equations. And if you remember those rules, then you don't need cast diagrams. They're weird. It's all in the graphs. There's a few things in A level that I sort of refuse to do out of moral principle. Yeah. No, so you can either use cast or graphs, but graphs is the way to go, so definitely do that. Okay, I'll do one more. So we've done sine and cos, so let's do tan now. Let's say we want to solve tan of x equal to 1.56. Again, let's do between 0 and 360. So tan's slightly different compared to the sine and cos graph. So you can see sine and cos, they're sort of bounded. They're stuck between between 1 and -1. So they always are stuck in here. So whenever you're solving, you're always going to be solving something like 0 points, like here, or minus 0 point something. But tan can go, as big or as small as it wants. So that's something to bear in mind. So let's sketch this again. Just rough sketch. $90, $180, $270, $360. So we know we've got these asymptotes here and here. And our graphs look something like this, this, this. This is our graph. So this is the actual graph bit we're interested in. And what do we want? We want this to equal 1.56. So let's say that's here. So this is 1.56. So what do we want? So this is where they intersect, here and here. So we want this point here and this point here. So these are the x values we're looking for that solve our equation. So as you can see, again, the graph makes it really clear what we need to do. It takes it from some sort of equation, which doesn't really mean anything. It's sort of, what does that mean? But looking at the graph and seeing it, you're saying, okay, so we want this point here and this point here. That's the solution. So tan's really easy. So we can do tan inverse of 1.56. Again, this always tells us the first one. So if you write in your sort of things here, so we're between zero, we know we're looking for something between 0 and 90, we get 57, which makes sense. So x1 is tan inverse of 1.56, which equals the 57.3. Now remember, for tan, it just repeats every 180. So when you're solving for tan solutions, it's really easy. You just find the first one and just add 180. And that's the next one. Or so the second solution is that plus 180, so 237.3 degrees again. So to get from here to here, you just do plus 180. And you just keep doing that. Plus, or you can subtract 180. So if you wanted to find a negative solution, minus 122. So if we do tan of that, then we get 1.56 again. So you just do plus or minus 180 degrees. Okay, so nice and easy. So I just wanted to touch on sort of the rules then. So if you're going to write anything down or just try and learn anything, I'd say this is probably the most important bit. This is the thing which you get the most value from, sort of the rules for trig equations. So rule number 1, sine of x equals sine of 180 minus x. So what's that saying? You wrote the first answer in 3 sig fig and the second one in 4 sig fig. Yeah, I guess. I was just more doing 1 decimal place. It doesn't really matter, to be honest. Anything like this is fine. You can put 2 decimal place, 1 decimal place. It doesn't matter. What calculator am I using? This is a Casio FX83 GT, but this isn't. You should get a different one. You should get a newer one. This one's really old. There's a lot of newer ones out there which can actually do a load more stuff than this. So I think there's new Casio ones. Look online. I'm not sure the specific models, but Casio is quite good. So this is the first rule. Sine of x equals sine of 180 minus x. So what does that mean? It's saying when you get your first solution for a sine equation, you just do 180 and take away that. So 26.94, we do 180, take away that, and that gives us our second solution. That's the first rule. The second rule, cos of x equals cos 360 minus x. So similar to the first one, when we find our cos answer, so we did 100, we got 140, we do 360, take away that to get the second one. The third rule, tan of x equals tan of x plus or minus 180. So that's what we saw here. If you have a tan solution, you can just add 180 or subtract 180. Tan's really easy, so just remember that. And then the fourth rule is that sine and cos repeat every 360. So if you wanted to find all the solutions for sine, you'd do the first one, do that on your calculator, then do 180 minus that and get the second one. And then for each of those, you can add and subtract 360, and that's going to start giving you all of the solutions. So these are the rules. If you have a trig equation, this is what you do. You don't need a cast diagram. You don't even need to sketch the graph if you don't want to. I think it's useful just to have a little sketch. But if you remember these rules, then you're good to go. So get that sort of tattooed on your arm or something. You're sorted. What is a cast diagram? So a cast diagram is something like, I can't even remember. It's A, C. I think it tells you for which values of theta, which is positive. So I want to. So if theta's between, this is like 0 to 90 degrees. If you're between 0 and 90, then all. So A means all. So sine, cos, and tan are all positive. If you're here, between 90 and 180, only cos is positive. If you're here between 180 and 270, sine's positive. If you're here between 270 and 360, tan's positive. Which is a bit, I mean, if you remember what the graphs look like, then you can sort of see when it's positive and negative. So they're a bit redundant, I think. So sort of forget that. Just ignore that. A lot of the textbooks talk about this, but you don't need to. Don't need to worry about that. Just remember these. Remember the 4 rules. So write that down. I'll leave it up here. Learn these rules, and then you'll be pretty good. Okay, cool. So that's sort of all the information so far. I think, could you show the beginning if you used your cos graphing it? Yeah, sure. This one? These are the graphs, or you can look up the graphs. I mean, the search like trig graphs, it will tell you all 3 of them, and you can find those. Okay, so I'll do a couple more examples using the identities we've learnt. Yeah, so the tan lines, it only comes about because we use tan theta is sine theta divided by cos theta. And when cos is 90 and cos is 270, we're dividing by 0. And you can't divide by 0, so it goes off to infinity. That's why we have these lines here, which are the asymptotes. Okay. I'm going to move on to a couple slightly different questions. So I think I might leave this one as a a little exercise for you, and you can write your answer in the chat if you can do it. So solve 3 sine x equals 4 cos x between 0 and 360. So 3 times sine x equals 4 times cos of x. There should be 2 solutions. So write in the chat just to like the nearest degree or to 1 decimal place, doesn't really matter if you know how to do this. So it's slightly different to the ones we've done before. So you're going to need to use some sort of identity. So have a go, have a think. Or you can even put in the chat sort of like the steps to do it. Sort of there's one sort of key step. So if you know what that is, then put that in the chat and we'll have a go. I'll give you a couple of minutes and then we'll go through it. Do inverse operation to make sine of x on its own? No, not quite. So I quite like this question. It looks really simple, and the answers actually, there's a nice little trick you can do it. Yeah, there we go. Someone said it. Can we make it to tan and then do the graph? Yeah, exactly. So we want to use. So I was right. A solution. We want to use that tan of x equals sine x over cos of x. So this relationship you should just know sort of off by heart. This comes up all the time. Yeah, there we go. Someone's put the answer 53.1 233. That is correct. So this is how you do it. So we use this relationship. So if we take our equation and then divide both sides by cos, that means that 3 sine of x over cos of x equals 4. So I've just divided both sides by cos. Now we use the tan bit here. So that means that 3 tan of x equals 4, which means tan of x equals 4 over 3. And now this is like we've seen before. We've got just a simple trig function equal to a number. We can do inverse tan of 4/3. Gives us the 53. So tan inverse 4/3. And this is 53.1 degrees. And remember the rules for tan, we just add 180. So 233.1. So there you go. So this is quite a nice little question because it seems really simple. There's a cos and a sine. So if you've got something like this with 2 trig functions, you always want to try and turn it into just 1 trig function, because when it's like this, tan of x equals to something, we can do inverse tan. Okay? So yeah, write it down, everyone, if you didn't catch that. We divide by cos just to simplify the equation, turn it into a tan, and then we can go from there. Okay? Cool. I'm going to move on to the next one. So this is quite a nice one. Given that cos of A equals 5/13, and 270 degrees is less than A, less than 360. So we've got cos of A is 5/13, and A is between 270 and 360 degrees. We want to find sine of A. And you want to do this without a calculator, if possible. Yeah, so think about what identity we might need to use. Someone said sine squared of A plus cos squared of A is 1. So yep, that's going to work. So I'll make it, so if I write that down, sine squared of A plus cos squared of A equals 1. So this was one of the identities we saw earlier. And we know what cos of A is. Cos of A is 5/13. So cos squared of A is 25/169. That's just squaring that number. So you can square top and bottom on your fraction. So what does that mean? Sine squared of A equals 1 minus 25/169. So sine squared of A equals, so just simplify that, 169 take away 25 is 144/169. So everyone put in the chat, what is sine of A? If we've got a fraction here and we've got a squared, what do we do? So as a hint, it's going to be a fraction. So you can just type in as a fraction what you think the final answer is for sine of A. 12/13. Anyone else? 12/13 again. Same. 12/13. Well, unfortunately, you've all fallen into my trap, and you've made the classic mistake of forgetting that when we do a square root, we end up with a plus or a minus. So it can either be plus 12/13 or minus 12/13. But which one is it? So someone put in the chat plus or minus 12/13. Someone just put minus 12/13. Someone just put plus. So which one is it? Is it the positive one? Is it the negative one? Is it both? Is it neither? Which one is it? And what are we going to use to work out and try and distinguish which one it is? So we've got a couple of people saying positive. We've got someone saying negative. So if you think it's positive or negative, just what's your reasoning? Why do you think that? Someone else says negative. Anyone know why? Someone says positive. Any idea why? If you think it's positive or negative, why do you think? Question mark. So let's think about the graph. We're trying to find the angle sine. We're trying to find sine of A, and A is between 270 and 360. So if sine looks like this, then we can draw in 12/13 and minus 12/13. So this is sort of y. This is like our A axis almost. So this is plus 12/13, and this is minus 12/13. And we're told that A is between 270 and 360. So it's down here somewhere. So between 270 is 270. So this is 270. So it's actually, this is the one we're interested in. And this corresponds to the negative. So because sine is negative between 270 and 360, when we take the square root, we have to say it's not this one, it's this one. So sine of A equals minus 12 over 13. So again, that's a nice little question. It's got a few things going on. We need to use an identity. We have to be super careful when we do the square root. So this comes up all the time in exam questions. So it's another thing I'd probably write down if you're sort of studying A levels, is when you end up with a sine squared or a cos squared or a tan squared equals to something, or anything really, like an x squared, always remember plus or minus when you square root. No, this is A level, it isn't GCSE. I mean, it could be GCSE. If they said, it could be a sort of a tricky GCSE question. It wouldn't be as complicated as this, but in GCSE they could say something like, I don't know. They can say something basic like if x squared equals, I don't know, 144, find x. This is sort of a basic example. So what you don't want to do is just say, oh, x is 12. You need to say, or x is minus 12. So it's remembering both is what they're looking for. So that's the sort of key takeaway point. That applies here in this sort of context as well, whenever you're solving any sort of quadratic. So how can you see that? So the way to really see this is to factorize. So what's that saying? That's saying x squared take away 144 equals 0. And now we've got like a difference of two squares. So this is the same as x take away 12, x plus 12 equals 0. So here we get x is 12, and here we get x is minus 12. So factorizing is really the key. It means you don't forget. If you factorized it, you get both solutions. It's just when you square root it, it's easy to forget. So always try to factorize where you can, is my advice for A level or GCSE, really. Okay. It's getting on for 12. We'll do one more. Yeah, it's got to be this one. So this is the last question for today. So this is like a harder question. I'd maybe A/A star question, that sort of level. But we should be able to solve it using what we've learned today. So we want to solve 2 sine squared x plus sine x take away cos squared x equals 1. And again, between 0 and 360. So have a think. Maybe write in the chat what we're going to use, what's our strategy, any sort of first ideas. So here's the strategy. So solve 2 sine squared x plus sine x minus cos squared x equals 1. So our strategy is we want to turn this into a quadratic, all involving just one trig variable. So we can see we've got sort of the squared terms there. So that is making us think it could be some sort of quadratic equation. So what identity could we use to get this all in terms of sine of x, for example, sine of x and sine squares of x. Which identity do we know relating the sine and the cos? So we used it earlier. Yeah, sine squared x plus cos squared x equals 1. So we know that sine squared of x plus cos squared of x equals 1. And we think this is going to be useful because we've got sine squared, we've got cos squared. So this identity involving those is probably going to be useful. So let's rearrange this. Let's make cos the subject. Cos squared of x equals 1 minus sine squared of x. So this here, we're going to sub in up here into our equation, and that's going to give everything in terms of sine. So that means we get 2 sine squared of x plus sine of x minus, and now you need to be really careful with your brackets. So many people could slip up here. So in brackets, 1 minus sine squared of x, and this equals 1 still. Okay, so now it's all in terms of either sine or sine squared. So why is that helpful? Let's rearrange. Let's simplify. So 2 sine squared of x minus a negative, so a double negative makes a positive. So that's going to be plus another one. So it's going to be 3 sine squared of x plus sine of x. And we've got minus 1 here, and we can subtract this one onto the other side as well to get minus 2 equals 0. So this now is starting to look like a traditional quadratic equation. The only difference is we've got this sort of sine squared, we've got sine. So how you can think about this is saying something like, okay, let y equal sine of x. So what have we really got? We've got 3 times something squared plus something minus 2 is 0. So this is just a quadratic equation. So sometimes this is known as like a hidden quadratic. So you can either introduce like a new variable just to make it clearer, just so you can see what's going on, adding in like 3y squared plus y minus 2, which you can factorize, or you can just do it straight away. So this actually factorizes. So we know we're going to have a 3 sine of x here and a sine of x here. And what do we want? They need to multiply to minus 2. So it's going to be a 2 and a 1, or a minus 2 and a plus 1. And also they want to add, when we multiply it out, to a plus 1 here. So if we put a minus 2 here and a plus 1 here, then that should do it. So now we've got a quadratic, we've factorized it, and now we split it off into 2 separate cases. So this means that sine of x equals 2/3. Or in this case, split it off, sine of x equals minus 1. But we're not done yet. We're not done, because remember, we don't want to find sine of x, we want to find what x is. Exactly, yeah. So someone's put it in the chat, so that's perfect. Oh, not quite perfect. One small mistake, but we can go through it. So we look at them separately. Is 41.8. And then what's our rule? We do 180, take away that answer. So it should be 138.1. And the last one is sine of x equals minus 1. So sine inverse of minus 1 is minus 90, but that's outside of our range. We want it to be between 0 and 360. So what do? We add 360 to our solution because it repeats every 360. And we get that x is equal to 270 degrees. Now this is the only one because remember, we do our rules again. So we could have done 180 and then do 180 minus that answer. And that again gives us 270. So that's 2 separate ways of doing it. And if you think about the graph, it only hits minus 1 once. So there's only one solution here. whereas for 2/3, along here, it hits it twice, like here and here. So we only get one solution for this bit and two for this bit. So it's these three, these are the solutions. Okay, so the strategy is use an identity to turn it into a quadratic in just one trig function, and then we can factorize, solve, rearrange to get our x values. Okay, cool. So that's all I had for today. I mean, trig is a huge topic for A level, so there's loads more questions. So I might do another lesson on trig, doing some slightly harder questions because there's loads of questions. So let me know if you're interested in more trig or a different topic. But yeah, so I'll leave it there for today. I'll upload the full recording of this onto YouTube, hopefully later today. Any questions, please let me know. Either message me on Instagram or email me. I'll put it in the chat. Just send me an email if you want. Add there. Subscribe to me on YouTube as well so you can see the notification. If you search Maths with Chris, you should find it. If not, if you go to my Instagram bio, I've got all of the links in there. And as a thank you for everyone in the Zoom chat, I'd like to say you all entitled to a 20% discount. So I write it in, 20% discount on any membership or video lessons. So you can see all the details there, here. So either 20% off on membership or on a video lesson. Just drop me a message. Just say you came from the trigonometry lesson. I mean, there's only 16 people here, so I remember most people's names anyway. So let me know. Or if you need help with any questions, that's what the membership's for. So you can sort of message me a question on WhatsApp. We've got a couple of members in here today, I can see. So I'm sure they can sort of say that it's good. You know, I can really help people. They've seen a lot of improvements. And if not, then there's also video tuition, which is sort of more private one-to-one. So we can go into a lot more detail. That's where I sort of go through loads of questions like these really slowly for people. We go through all the details, all the explanations, the graphs, the different ways of thinking about it, so I can get to know you better and how I can really help. I've seen a lot of, I've got a few students at the moment and their confidence has really gone up. So if you're interested in that as well, 20% off for you guys as a thank you. So thanks so much for coming. And yeah, let your friends know as well. It's every Saturday. I'll try and do it Saturday morning at 11. So I'll do one next week. Because you filled out the Google form, I've got your email. So I'll just email everyone again the link next week. Same time, same place. Yeah, okay. Thanks everyone. And I will see you next week. I haven't decided a topic yet. So just let me know any suggestions. Email me or DM me on Instagram. It's probably easier. Any specific questions, topics, whatever, it's up to you guys. Okay, cool. Thanks everyone. I'll see you next week.